Okay, today we're going to talk about limited reactant problems. And what is a limited reactant problem? More important, how do you know it is one? Well, there are certain clues in the wording of the problem. One of the clues is they'll ask for the maximum amount of material available from two reactants. What are reactants? Reactants are on the left side of the equation, products are on the right side. Another thing, they'll ask for a limited reactant. Well, that's pretty easy to know that it's a limited reactant problem. Now, what steps do we have to do to solve it? First thing we have to do is make sure the equation is balanced. Some instructors and some problems will not have the word balance in there. If it does not have the word balance in there, don't assume it's balanced, check. Because if you don't get that balanced equation correct, the rest of the problem may be incorrect. Second is you determine the amount of product produced by each reactant. The least amount of product is going to be the limited reactant. What tools? Again, periodic table and calculator. So now let's talk about problems. First one, the reaction of methane and water is used to prepare hydrogen. If you begin with 995 grams of methane and 2510 grams of water, what is the maximum possible yield of hydrogen, given the balanced equation below? First key, maximum possible yield. That's a flag. Second, you're only given the reactants. You're given methane and water and asked for what's the maximum amount of hydrogen. That is another clue. So now, what we need to do, since we know the equation is balanced, is determine the amount of product produced by each reactant. To do that, we take what we have. What we have, well, we're going to do methane first. We have 995 grams of methane. Okay, now we need to convert it to moles of methane. We know that 1 mole of methane is 16 grams of methane. Now we need to find a relationship between methane and hydrogen. Because how are we going to produce it unless we have that relationship? And that relationship is going to be based on first getting the number of moles of hydrogen, then converting that to the grams of hydrogen. So let's look around here. We know for every mole of methane, we get 3 moles of hydrogen. So we have that, but again, based on our theory here, we always have to cancel, so the mole of methane will be on the bottom. So we will have methane, and on the top, we will have hydrogen. Okay, but what's the ratio? It's going to be 3 to 1. It's going to be 3 here and 1 here. Now, we have now converted our answer into moles of hydrogen, but we're going to ask for grams of hydrogen in this problem. Okay, so now we know we have the moles of hydrogen on the bottom, and then we have the grams of hydrogen. And again, from the periodic table, which is already put here, we have 2.02. Okay, also, if you notice, I made a little bit of an error here because I used a different periodic table. So always go by the information on the problem or the current periodic table you have. So it's going to be 1604. When you multiply this out, your answer will be 375.9 grams of hydrogen. Now again, notice how everything cancels out. The units is what we're worrying about. So the final answer is going to be grams of hydrogen. Now we're going to do the same thing for water. We now have 2510 grams of H2O. Again, we want to convert it, and we have the conversion factors right here. So we have 1 mole of water over 18.02 grams of water times same relationship, 3 to 1. Then we do the same conversion, 2.02 grams mass multiplied out. Well, in this case, it's pretty obvious which reactant produces the least amount of hydrogen. This one. So this is the limited reactant. Now on to problem 2. Given the balanced equation, which is this one right here, we also have the molar masses. Starting with a mixture of 32 grams of sulfur and 71 grams of chlorine, what is the limited reactant and how much S2C2Cl2 in grams can be produced? Again, the same approach. We look at each reactant, and the one that produces the least amount will be the limited reactant. So we set this up, and let's do sulfur on this case. Okay, sulfur. We have 32 grams of sulfur. Now we want to convert it to moles. So we have 1 mole over the molar mass of this material, 256.6 grams. Now we have to get the moles. Now, where do we get this? Again, we look at the ratio in the balanced equation. In this case, we have 1 and we have 4. Now, we now need to get the grams. So, same thing, we do relationship 1 mole of S2Cl2 over 135 grams of S2Cl2. And then when we multiply this out, again, remembering to do this correctly, these units must have to cancel. So this has to cancel with this. This has to cancel with that. This has to cancel with that. And we get S2Cl2. And that number is going to be 67.3 grams of S2Cl2. We now have to do the same thing and see how much of this is produced from this. So we have again Cl2. We go to 71.0 grams of Cl2 because that's what we have. Again, we convert it to moles. And because this is diatomic, we have to take the periodic table and again multiply the molar mass of Cl by 2. In this case, we don't have to do it, but in case you didn't have this number here, that's how you would calculate it. Then we have to do the same ratio. Now, notice the ratio. It's going to be S2Cl2 to now Cl2, not sulfur. So let's look up here. 4 to 4. Then we convert to grams. So we have 1 mole of S2Cl2 here, and we have from the information above 135 grams of S2Cl2. When we multiply that out, we get 135.2 grams. Okay, let's go back and look at the problem. The problem wants to know what is the limited reactant, how much S2Cl2 in grams is produced. Well, based on what we said, the least amount of product is the limited reactant. So what produces the least amount of product? Sulfur. So sulfur is the limited reactant.